All right, looking at worksheet on differential equations. Number 1, especially concerned about the negative thing. And I do wonder if it's a plus or minus thing that maybe we forget about. dy dx equals x squared over y, given, and I'm just going to write it as a point, 3 negative 5. So that's what we'll use to find c at the very end. But for first, we'll separate the variables, integrate both sides, and go from there. So y dy equals x squared dx. Integrate both sides. Both pretty straightforward power rules, so nothing crazy. No u substitution needed. Y squared over 2 equals x cubed over 3 plus c. To get y by itself, y squared, and multiply through by 2, 2/3 x cubed plus c, right? Because I haven't committed to c yet, so c is still just anything. If you want to call it a different c, that's fine. If you want to call it 2c, that's fine. And then to solve for y, we put the square root on. But when we square root both sides, we have to remember to think about the plus or the minus. And that's where the negative is going to come from. Because to get negative 5 for an answer, we would have to pick the negative one. So let's see, negative 5 equals, got to be the negative one, square root of, let's see if this is rigged to work out in our favor. And it kind of looks like it is, because 3 cubed is 27. 2/3 of that is 18. Then we could square both sides, or we could look at it. Some of you could just look at that and figure out what the c need to be to make it work. But I guess the official way would be square both sides. And c equals 7. So y equals negative square root 2/3 x cubed plus 7. Because I needed my answer, my y value was negative. So the only way I was going to get negative 5 for an answer is if we picked the negative square root.
It's always just dependent on the y.
Correct. So it doesn't happen often. There has to be a square root for it to matter. And then for you to even have to think about it, the y would need to be negative for you to worry about it. What else? Let's do a couple more.
What number was that?
That was number 1. Other questions, especially 1 through 8.
7.
Number 7. What's that? Find an equation of the curve that satisfies. We try to write the problem a couple different ways, but they're all kind of the same. Whose y-intercept is 7. Okay, well, why don't we just translate that to a point? If the y-intercept is 7, what point is that? 0, 7. So it was just a different way of giving you a point. Okay, dy over y equals 4x cubed dx. Separate the variables. Integrate both sides. This shows up a lot. Give away the answer. What's the integral of dy over y? Natural log of y. The antiderivative of 4x cubed. Increase the power by 1, divide by the new power. And you're back to just x to the fourth. And then we've done this, well, not quite 100 times yet, but 4 or 5 times already. The loop-de-loop thing. So e to the x to the fourth plus c equals y. And then we can kind of switch our c's around and put that c at the bottom, or as a coefficient. It's a different c. That's not the same value, but we don't have a value yet, so it doesn't matter. Okay, so that's the general solution. I need to make sure I use these words, because there's a c in there. The particular solution means use the point to figure out what the answer is. So plug in 0, 7. In for y, 0 in for x. They gave us a nice one to work with because e to the 0 is 1, so c is 7. So the answer is 7e x to the fourth. Other questions on 1 through 8? Just kind of looking at them. Nothing looks too crazy. 6 looks crazy, but we did 6 yesterday. Number 8. Find an equation of the curve. Again, we're trying to reword these just to make you think a little bit, but at the end of the day, they're all kind of the same question. Find the equation of a curve that passes through the point 1, 1, whose slope is y squared over x cubed. But what's another way to say slope? dy dx. So again, it's the same type problem. We just try to word it weird because AP test sometimes does that. Keep you on your toes. And give you an easy problem but with different words, and sometimes people get confused. Okay, so moving things around, dy over y squared equals dx over x cubed. I don't like that because I'm going to mess that up if I try to antiderivative something in the bottom. So I am going to take the time to rewrite it as y to the negative 2 and x to the negative 3. So now it's just the power rule, although negative, so be careful. So increase the power by 1, divide by the new power, increase the power by 1, divide by the new power, plus c. Okay, we got an algebra mess incoming here. Thoughts on what we could do first on this? I think there's one obvious first step to start to get y by itself. Maybe it's not so obvious. It does need to go on the bottom. That's the negative 1 part. But even before that, I'm going to multiply through by negative 1 because that'll make them positive. They're not broken, but I can make this minus c, or I could just leave it as plus c. Right? It doesn't matter because I still haven't committed to what c is. So I'm just going to call it plus c. Even though that's now a different c. So sometimes I'll put a subscript on it to just kind of make a note that didn't have to change the sign, but that means that's a different value there. Okay, so that's 1 over y equals 1 over 2x squared plus c. Maybe the easiest thing to do is to just, well, flip the whole thing. But if we do that, we got to flip this whole thing together. We can't like flip the pieces. So 1 over 2x squared plus c. Ugh. To get y by itself. That's a safe stop answer, perfectly okay. Well, once I plug in 1, 1, figure out what c is. A calc chat, a multiple choice, the AP test is going to probably clean that up. And they're going to clean it up by multiplying through by 2x squared over 2x squared. That way we don't have fractions and fractions. Alright, let's plug in 1, 1, figure out what c is. So now it's an algebra problem, right? Calculus is over. 1 equals 2 over 1 plus c, 1 plus 2c, excuse me. So 1 plus 2c equals 2. 2c equals 1. c equals 1/2. Algebra, 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 algebra on this problem. But now I know what c is. So my final answer is 2x squared over, if c is 1/2, 1/2 times 2 cancels each other out. What a lovely problem. Although I think the ugliness on that problem is from the algebra, not really from the calculus. The calculus wasn't too bad. It was all the algebra of solving for y and then finding c. Anything else from 1 through 8?